Okay, welcome you all to the lecture on boiling. So first of all, let me talk about what exactly boiling is and how it is different from evaporation, right? Because see, all of us, in fact, we do have a little bit of, you know, misunderstanding about boiling. We generally think, when I was a student, I used to think like there is no difference between boiling and vaporization. So, so I just want to talk about boiling, right? So first, exactly, let me talk about what boiling is. Now, you see, boiling is definitely, there's no doubt, it is phase change. It is phase change. Now, if I ask you the question, what is the difference between boiling? What is the difference between boiling and evaporation? So if I ask you this particular question, what is the difference between boiling and evaporation? you know you may give me the answer, but the thing is, you will definitely say that both boiling and of course evaporation evaporation are related to phase change. Now let me talk about how boiling is different from evaporation, right? We know both are something related to evaporation itself, phase change itself. Now you see the difference between boiling and evaporation is boiling occurs at solid liquid interface, whereas evaporation occurs at liquid vapor interface. I hope you understand now what I'm talking about. Now let me take a kettle. Let me take a kettle and I'm just giving heat from this end. I'm just heating it, okay? I'm just heating it. And inside I have some liquid. Let us say, why don't we call it water? Okay, so I have water inside it. Fine, I have water inside it. And water is at, of course, normal atmospheric pressure, which is 1 atmosphere. Now this, this is what we call, this is solid, of course, this surface, this is solid, and inside I have liquid. And this is liquid, and here I have vapor, right? So what is this interface? This interface, I can call it as solid liquid interface, right? This is solid and this is liquid. So the differentiator, I mean, this particular layer, I can call it as solid liquid interface. Okay, so this is like, I have a pan, and on the top of that, let me suppose I have some water. Okay, on the top of the pan, if I suppose I have some water, then I can say, like, that particular layer of water, just give me a second. Okay. So the layer, the liquid layer, which is on the surface, that layer or that imaginary interface, we call it as solid liquid interface. And this is, you know very well, this is vapor and this is liquid. So this would be liquid vapor interface. Am I right? Now, if you observe very carefully, that boiling occurs here. You see small, you see the rise of small bubbles. Initially, they occur at this particular, at the surface of the pan, right? So what is that surface? That surface is nothing but the solid liquid interface. So boiling always occurs at solid liquid interface, right? Whereas you see vaporization, what happens? These bubbles rise up and they will, these bubbles just, they vaporize. That means from the surface of the liquid, they just evaporate, right? They just evaporate here. So evaporation always occurs at what? Evaporation always occurs at liquid vapor interface. So you got to be very careful about this, right? Because most of the people think that boiling is same as evaporation. No, it's not. You cannot call this, where the liquid to vapor phase change is taking place, that you cannot call it as boiling, because boiling always occurs at the surface of the heating element. Boiling always occurs at the surface, that is a solid surface. Boiling always occurs at solid surface. I will write here, boiling always occurs at a solid surface. Remember, if there is no solid surface, there will not be any boiling. But for evaporation, you don't need that. If you have a pool of liquid, and by some means, if the liquid is heated up, what happens? Liquid gets evaporated. So evaporation always takes place at the liquid vapor interface, or liquid gas. Vapor is nothing but some gas, right? So liquid gas, or liquid vapor interface, whereas boiling should always occurs at a solid surface. So boiling always occurs on the solid surface, where you have on the top, on the solid surface, where you have some liquid. It can be either water or some other liquid for that matter, right? So what I mean to tell you is, boiling always occurs at solid liquid interface. Try to understand this. Fine. Now, what is boiling exactly? Boiling is simply convection, which is, you have seen right now. So if the surface of the pan is heated up, so what is happening? The liquid inside it, what happens? The surface of the pan gets heated up, and that heat is converted to the liquid. So boiling is simply convection. We know heat transfer taking place from a surface to liquid, or for that matter any fluid, we call it as convection. So when we say liquid, boiling should happen at a solid liquid interface. It's not gas. No, boiling should happen at solid liquid interface, right? That is the reason I'm not saying fluid, because when I say fluid, it could be either gas or liquid. But no, boiling should occur at the interface, or boiling should occur at solid, which is solid surface, on which you have certain liquid. Underline that, liquid. Okay, so boiling is simply convection with phase change. Am I right? Why phase change? Yes, because you will have small bubbles. What is that bubbles? What would be there inside bubble? Inside bubble you have certain vapor or gas. So it is phase change. Phase is being changed. You have two phase, both liquid as well as vapor. When it is occurring at a solid, when it is occurring at a solid surface, so you have all the three interfaces. What is that? Solid, which is solid surface. You have liquid, and when the bubble arises and the bubble pops up, then it is gas. So it's actually a triple point, right? So you got to be very careful about this. Now, so generally, just like Q convection, Q boiling is also same as HA delta T. What is delta T here in this case? Instead of T, delta T is surface temperature minus liquid temperature, but we do not know what the liquid temperature is. Liquid temperature could be anything. So that is the reason generally we take this saturation temperature. What is the saturation temperature of water? At 1 atmospheric pressure, the saturation temperature of water at 1 atmospheric pressure is 100 degree Celsius, right? So delta T is Ts minus Tsat, and this Tsat is depending on the liquid. If the liquid is water, which is at 1 atmospheric pressure, normal atmospheric pressure, then obviously it would be 100 degrees Celsius. So that is the reason we call it as excess temperature difference. Generally, Ts, it depends on your heater. So whatever the heat input you give, that based on that, your surface temperature would be. Of course, if you give more heat input, your surface temperature will increase, right? So, but generally Ts is the surface temperature, and Tsat, see, normally what we say, Ts minus T infinity. Until now in convection we have seen delta T is Ts minus T infinity, right? But in this case, the infinity, we do not know what that ambient liquid temperature, because ambient liquid temperature keeps on changing. Ambient liquid temperature will change, right? So that is the reason we call it as excess temperature. Until what point it will change? Until what point it will change? Until it reaches the saturation temperature. Let us suppose you have a pan like this, and on the top of that you have inside it you have certain liquid, or let us suppose you have water, okay, which is at 1 atmospheric pressure. Fine. So when water is at 1 atmospheric pressure, you are inputting heat, okay, this is surface temperature, and until water reaches saturation temperature, its temperature gets increased. Until water reaches 100 degrees Celsius, temperature keeps on increases. Once the water inside the kettle reaches 100 degrees Celsius, what happens? Temperature further, the further increase in temperature will not happen. Why? Because at that point, boiling takes place at the solid liquid interface. At that solid liquid interface, what is happening? You will have phase change. So whatever the heat input you give, that will not be used to increase the internal energy of the liquid. Thereby internal energy increase ayindante, your temperature will increase of the liquid. But when it reaches the saturation temperature, which is for 1 atmospheric pressure for water, if the water reaches 100 degrees Celsius, which is at 1 atmospheric pressure, which is nothing but the saturation temperature, then what happens? The further increase in temperature of the water will not happen. But the boiling, the phase change takes place at the solid liquid interface, right? Is that clear? So that is the reason, instead of saying Ts minus T infinity, I know that T infinity will not reach any value as it wants. I know that T infinity can reach up to T saturation. So that is the reason, instead of saying delta T, I will call it as excess temperature difference, which is nothing but Tsat, which is surface temperature of the heater minus saturation temperature of the liquid inside the pan or whatever you take. That is the saturation temperature of the liquid basically. Okay, so this is very important. This is your excess temperature, which is the difference between surface temperature of the heater and the saturation temperature of the liquid. Okay, this is watt per meter square. Okay, this could be either degree Celsius or degree Kelvin because it is temperature difference. Okay, just a moment. Fine. So excess temperature is Ts minus T sat. Is that clear? Okay. Now we have two types of boiling. One is pool boiling and flow boiling. So pool boiling, example of pool boiling, you have a bucket of water and inside it if you put your geyser, if you put your geyser inside it, what happens? You have your water inside it. Obviously water would be at 1 atmospheric pressure. So the saturation temperature is 100 degree Celsius. Okay, and heater, you on the heater, and what happens? Heater surface temperature would be something depending on the rating of your heater. Its surface temperature will reach to certain, and what happens because of this? Initially heat will be convected to the liquid. Okay, until it reaches 100 degrees Celsius. Initially let us say the liquid is at 20 degrees Celsius, which is the room temperature, okay. Once the liquid reaches the saturation temperature, which is 100 degrees Celsius, what happens after that? This is surface. Okay, this is surface Ts. You can see where the heat is coming up from this surface, right? So that is the reason the geyser surface is the surface of the heater, right? So that is the surface we consider. Surface temperature is Ts, and to what it is giving up its heat? To the liquid, right? Initially liquid at normally it would be at room temperature, so obviously it would be at 20 or 30 degrees Celsius. So it have once the geyser is on, what happens? The geyser will start giving, heat will be transferred from the geyser surface to the surrounding liquid until it reaches 100 degrees Celsius. Once it reaches 100 degrees Celsius, what happens? Once it reaches 100 degrees Celsius, Ts minus T set. Let us suppose surface temperature is 110. Let us suppose surface temperature is 150 degrees Celsius, and T set is 100 degrees Celsius. What happens? Initially, let us suppose surface temperature keeps on increasing, right? Surface temperature will also increase as the heat input increases. What happens? Surface temperature will also increases. So let us suppose initially, right, at one point, what happens? Both will be at equilibrium. That is 100 degree Celsius. So surface temperature would be 100 and T set would also be 100. But at this particular point, the temperature of the water will not increase further because it's already reached its saturation temperature, which is 100 degrees Celsius at that particular atmospheric pressure, right? Normal atmospheric pressure. Saturation temperature of water is 100 degrees Celsius. So at this particular point, excess temperature would be 0 degrees Celsius. So at this particular point, until this point, there will not be any boiling that you observe at the surface. But what happens when the surface temperature increases to 105 degrees, 101, 102, 103, 104, 105? So what happens? You will see small bubbles arising on the surface of the heater. Or if you take a pan like this, if you fill with water and you have given heating, so let us suppose your pan surface is the heating surface. So what happens? Initially, until 100 degrees Celsius, nothing will happen. After, if the water reaches 100 degrees Celsius, which is saturation temperature at one atmospheric pressure, what happens? If the further increase, if the further increase in heated temperature, further the heat cannot be given up to to increase the temperature of the liquid, right? So temperature of the liquid cannot increase further, but what happens? The surface temperature can increase. So as the surface temperature increases more than 100 degrees Celsius, what happens? If the delta T, Txs is greater than 0 degrees Celsius, that is 1 degree, 2 degree, 3 degree, and so on and so forth, but small bubbles will occur at the heating surface. So this is, see, this is the surface from which heat is being. So that is the reason boiling happens here. In this case, surface is the geyser surface, right? So that is the reason I have shown the bubbles on the surface of the geyser, right? Which is the heating. In this case, the heating element is the surface itself, surface of the pan. In this case, the heating element is the geyser. So the surface of the geyser, on the surface of the geyser, boiling will take place, because boiling always occurs at solid liquid interface. Am I right? Fine. When boiling happens in this kind of situation, because since you have a pool of water, stagnated water or stagnated liquid, when boiling happens, when boiling happens in stagnated liquid, then we call it as pool boiling, right? Now come to the next one. What is that? Flow boiling. Imagine you have a tube and you have a pump here. And water is being pumped inside. So water is flowing at certain velocity. And if you have heating coil, or if you have heating element to the surface of the tube, then what happens? The tube surface gets heated up, right? And the water which is flowing inside it, the liquid which is flowing inside it, it also gets heated up when the liquid temperature is greater than its surface temperature. When the liquid temperature is greater than the surface temperature, what happens? Boiling occurs. So on this surface, on which surface the heating element is, so because on the surface the heating element is there, so on the surface you will have small bubbles. But here the liquid is not stagnated, it is flowing. So when, or I should write with black pen, so when boiling occurs in flowing liquid, we call it as flow boiling. If it is a nuclear reactor, so there is no need of any heating element like this, and by the neutrons hitting the element, heat will be, but because of the nuclear fission, the surface gets heated up, and the liquid inside the tubes, the flowing liquid inside it, will get heated up, and you get the boiling, and that vapor from the boiling, you will get the vapor, and the vapor will be expanded into a turbine, and you generate the power. This is how nuclear power plants work. Okay, but basically you don't need to think in that complicated way. You think of it simply, you have a heating element, and the surface, because that heating element is wrapped onto the tube surface, the tube surface gets heated up, and if because of that heat will be transferred to liquid, and the liquid temperature is more than the saturation temperature, what happens? Yes, boiling will take place, right? So this is what it is. Okay, so this is the basic definition of boiling. Is that clear? Fine. and we will look into the boiling curve, how the boiling takes place, what are the phases in boiling, how the bubble generates. All these things we'll look into the next lecture. Okay.